In general, if x comma y is any point on the terminal side of an angle, we can set up our 6 trigonometric functions like this. I have my angle measured in standard position from the positive x-axis going counterclockwise, angle with positive measure. X comma y is on the terminal side of that angle, so y is my opposite side, x is my adjacent side. R we have to calculate. R is the direct distance from the origin to the point, and we can do that with the distance formula, the square root of x squared plus y squared, and there they are. They're my 6 trig functions. Sine of theta is opposite over hypotenuse, so that's y over r, and on through the list. The unit circle specifically is a circle of radius 1. I got a weird weather thing here. The sun keeps coming in and going out, so I'll try and keep up. In a unit circle, the radius is 1. That's really all a unit circle means. The radius is 1 unit. R is 1. But look what that means. I'm still looking at a point on the terminal side of the angle x comma y, but I want to look at specifically the point where that terminal side intersects the unit circle, whose radius is 1. The sine of my angle is still y over r, but if r is 1, I'm not going to write y over 1. I'm just going to write y. The cosine of my angle is still the adjacent side over the hypotenuse. It's still x over r, but if r is 1, again, I'm not going to write 1. I'm not going to write x over 1. I'm just going to write x because x over 1 is x. The tangent, oh well, nothing clever happens with the tangent. It's still y over x. And the other 3, the cosecant is the reciprocal of the sine, so that's 1 over y. R is 1 over y. The secant is 1 over x, and the cotangent is the reciprocal of the tangent, x over y. So for those special angles, the pi over 3s, the pi over 4s, the pi over 6s, we can look at where do those terminal sides cross the unit circle and just write them down and have them for easy reference. So I have points on the unit circle. And if I want to know, suppose I want to know what's the sine of 3 pi over 4. I'm going to set myself up strategically here. I want to know what's the sine of 3 pi over 4. Well, I'm going to come over here on my unit circle to an angle of 3 pi over 4. There it is. I'm looking at where the terminal side crosses the circle. Here it is. The sine of that angle is y. It's y coordinate. There it is, root 2 over 2. I can just read it off and I'm done. Sine of 3 pi over 4 is root 2 over 2. Suppose I want to know what's the secant of 4 pi over 3. Here's my angle, 4 pi over 3, down here in quadrant 3. The secant is 1 over the cosine, 1 over x. Let's see. The secant is 1 over x. Well, here's my x coordinate. The secant is 1 over that. So 1 over negative a half. Well, we're not going to leave it like that. We're going to simplify 1 over a half, also known as 2, and negative because we're in quadrant 3. There's the secant of 4 pi over 3. What if I want the tangent of 11 pi over 6? That's in quadrant 4. Here it is. 11 pi over 6 is y over x. So I'm going to put my y coordinate over my x coordinate. We can actually immediately say, okay, this what I got a 1/2 on the top, I got a 1/2 on the bottom. We don't need those. Really, I just need the numerators. -1 over √3, but we do rationalize these for the special angles. So that's -√3 over 3 is the tangent of 11 pi over 6. So the coordinates of any point on the unit circle are x, y. The x coordinate is cosine of my angle. The y coordinate is the sine of my angle. And I can use the unit circle like this to find the values of the 6 trig functions of any angle.